Hello everyone. In this tutorial, I will solve the exercises of lesson 1.1. I'll skip those I solved before. Number 1 to 4, match each function with its graph. We have 4 functions and 4 graphs. We want to match each graph to its function. Function number 1, it is linear function. Let me check it with the first graph. When x is equal -1, y should be -2, y should be 0. -1 times -2, 2, 2 over 2, 1 plus 2, 3, it's not 0, then this graph is not for this function. Let me check the second one. When x 0, y is 2. 0 plus 2, it is 2. When x is 4, -4 over 2, -2 plus 2, 0, it is the right graph. Then the first function with the second graph. Let me check the second function, 9 minus x squared. Let me check it with the first graph. When x is -2, then y is 0. 9 minus 4, -2 square, 4 minus 5, square root 5, it is not 0, then this graph is not for this function. Let me check this one. When y is 0, also when x is 0, also y is 0. 9 minus 0, 9, square root 9, 3, it is not 0. This graph is not for this function. Let me check the last one. When x is 0, y is 3. x 0, square root 9, 3, it's true. When x is 3, y is 0. 3 square, 9. 9 minus 9, 0, it's true. When x is equal -3 also is true, then the graph of this function is the last one. Let me check the third one, 4 minus x squared. Let me check it with the first graph. When x is 0, y is 4. It's true. When x is 2, y is 0. 4 minus 2 squared, 0. It's true. When x is equal -2 also is true, then this is the graph of this function. And sure, the last function, it is with this graph. Let me check it with the point. When x is 0, 0 minus 0, y also it's 0. When x is 1, 1 minus 1, also it's 0. When x is equal -1, -1 minus -1, 0, it's true. Question number 5 to 9. Sketch the graph of the function by point. For every linear function, I need only 2 points to sketch its graph. X, y. Let me take x 0, then y is 6. When x is 3, y is 0. I take y-intercept and x-intercept. Then x-axis and y-axis, 0 to 3, 1, 2, 3, 0 to 6, 2, 4, 6. This is 0, 6, and this is 3, 0. And draw a line passing through these 2 points. This is the graph of this function. Question number 8. Sketch the graph of this function. I take 5 points to sketch this graph. X, y. I take the point within the domain. Within the domain. I can't take a point like -3, because -3 plus 2, -1, square root -1, it's not a real number. Then I take, for example, -2 0, and negative 1. Negative 1 plus 2, 1. Square root 1, 1. I take 2. 2 plus 2, 4. Square root 4, 2. I'll take 7. 7 plus 2, 9. Square root 9, 3. It's enough. 4 points. 0 to 3, y. 1, 2, 3. And negative 2 to 7, negative 1, negative 2. 1, 2, 3, 4, 5, 6, 7. 0, negative 2. Sorry, negative 2, 0, this point. Negative 1, 1, this point. 2, 2, this point. 7, 3. As you see, the graph is look like this. This is the graph of this function. Question number 9. Sketch the graph of the function 2 over x. The value make denominator in a fraction function 0, it is vertical asymptote. In your future study, you will know what is vertical asymptote and horizontal asymptote. For now, x equals 0 is vertical asymptote. It's y-axis. Now I take some point lying on the graph, x, y. I take 3 points before 0 and 3 points after 0. 1, when x equal 1, y it's 2. When x equal 2, y equal 1, 2 over 2, 1. When x equal 4, it is 1 half. 2 over 4, 1 half. Then I take negative 1. When x equal negative 1, it is negative 2, y negative 2. When x equal negative 2, it is negative 1. When x equal negative 4, it is negative 1 half. Let me divide my axis. Y from negative 2 to 2. 1, 2, negative 1, and negative 2. Half. This is 1 half. This is negative 1 half. X, it's from negative 4 to 4. 1, 2, 3, 4, negative 4. 1, 2, 3, 4, 4. This is negative 4, and this is 4. Now I set the point on the xy plane. 1, 2, when x equal 1, y is 2. 2, 1, when x equal 2, y is 1. Here. 4 half. I have this graph. For the other 3 points, when x equal negative 1, this is negative 1. Y is negative 2. Here. When x equal negative 2, y is 1. Negative 2, 1. Here. When x equal negative 4, half. This is our graph. Question number 12. Find any intercepts for this function. The function is f of x equal x power 2 times square root 25 minus x power 2. For x-intercept, I set y equals 0. For x-intercept, set y equals 0 and solve to find x. Then 0 equal to x power 2 square root 25 minus x power 2. Square both sides. Then x power 4 times 25 minus x power 2 equal to 0. Analyze difference of two square. X power 2, x power 4, 5 minus x, 5 plus x equal to 0. Either x power 4 equals 0, this will give me x equals 0, or 5 minus x equals 0, this will give me x equals 5, or 5 plus x equals 0, this gives me x equals negative 5. These are the x-intercepts, 3 x-intercepts. For y-intercept, I set x equals 0 and set and solve to find the value of y. Then y equal 0 power 2 0 square root 25 minus 0, 0 times any number is 0, then 0 0 it's y intercept, and x equals 0, x equals 5, x equals negative 5 are x intercepts. Question number 13. For x intercept, I set y equals 0. Then solve to find x. 0 equal to x minus 1 square root x power 2 plus 1. Square both sides. Then 0 equal to x minus 1 power 2 x power 2 plus 1. Either x minus 1 power 2 equals 0, square root both sides, x minus 1 equals 0, then x equal to 1. Or x power 2 plus 1 equals 0, then x power 2 equals negative 1, then x equal to negative positive square root negative 1, not a real number. Then I have only one x-intercept. For y-intercept, I set x equals 0, then solve to find y. Y equals 0 minus 1 square root 0 power 2 0 plus 1, then 0 minus 1 minus 1 times square root 1 1, it is negative 1. Then 0 negative 1, it's only the y-intercept. Question number 14. For y-intercept, for x-intercept, set y تساوي equal 0, then 0 equal to x power 2 plus 3x over 3x plus 1 over power 2, then x power 2 plus 3x equals 0, cross multiplication, factorized by x, x plus 3 equals 0, either x equals 0 or x equal negative 3. We have two x-intercept as 0 and negative 3. For y-intercept, I set x equals 0 and solve to find y. 0 plus 0 over 0 plus 1 equals 0, then 0, 0 is y-intercept. Question number 15. Determine the symmetry of this function. 15 to 20. Determine the symmetry of this function. Let us check. Even minus even, it is even. Even minus odd, it is neither. Even over odd, it is odd. Odd plus odd, odd, absolute value of odd, it's even. Even minus, odd plus even, neither, square root, neither, neither, minus even, minus neither, it is neither. Easy. Point of intersection, find the point of intersection of these two functions from 21 to 24. Set f of x equal to g of x and solve to find x. F of x equal to g of x. 6 minus x power 2 minus 4 plus x equal to 0. Then minus x power 2 plus x, 6 minus 4 plus 2 equal to 0, times negative 1, x power 2 minus x minus 2 equal to 0. By experiment, x minus 2, either x minus 2 equal to 0, then x equal 2, or x plus 1 equal to 0, then x equal negative 1. This is the intersection point of these two graphs. If I want to find a y coordinate, then I substitute here 4 minus 2, it is 2, negative 1, 4 negative negative 1, it is 5. Question number 23. Set f of x equal to g of x, x power 3 minus 2x power 2 plus x minus 1 equal to negative x power 2 plus 3x minus 1. X power 3 minus 2x power 2 plus x minus 1 plus 2 plus x square minus 3x plus 1 equal to 0. Negative 1 with plus 1, with positive 1, then x power 3, negative 2x square or minus 2x square plus x square, it's minus x square minus 3x equal to minus 3x plus x minus 2x equal to 0. Factorize by x, x power 2 minus x minus 2 equal to 0, x, difference of, by experiment, equal to 0, either x equals 0 or x equal 2 or x equal negative 1. When x equals 0, then 0 plus 0 minus 1, it's negative 1. When x is 2, negative 4, negative 6, negative 1, plus 6, 2 times 3, 6, minus 1, 2, 2 minus 1, 1. When x equal negative 1, negative 1, negative 3, negative 1, it is negative 5. I hope I substitute correctly. Question number 24. Set f of x equal to g of x, 6 with 6, then minus 2x minus 3 equal to negative x times negative 1, then absolute value 2x minus 3 equal to x. Since I have absolute value, I should remove it. I used the definition 2x minus 3 equal absolute value equal to 2x minus 3 when x greater than or equal. Let me find the joint point here. 2x minus 3 equals 0. 2x equal 3, x equal 3 over 2. Then the joint point is 3 over 2. and negative 2x minus 3 when x less than 3 over 2. I solve both cases. Absolute value 2x minus 3 equal to 2x minus 3 when x equal greater than or equal 3 over 2 equal to x. Then 2x minus x equal to 3. Then x, 2x minus x equal to 3. 3 greater than 3 over 2? Yes, it's greater. Then it is the intersection point. If I want to find the y coordinate, 6 minus 3, it's a 3. Then 3, 3 is the first intersection point. For the other case, negative 2x minus 3 equal to x. Then negative 2x plus 3 equal to x. Then x plus 2x equal to 3. Then 3x equal to 3. Then x equal to 3 over 3, 1. 1 less than 3 over 2? Yes, it is less. Then it is intersection point. To find y coordinate, substitute here 6 minus 1, 5. 1, 5 is another intersection point. Question number 26. Write the equation of the function that has 3x intercept as x equal negative 2, x equal 4, and x equal 6. X equal negative 2, the bracket is x plus 2. X equal 4, the bracket is x minus 4. And x equals 6, the bracket is x minus 6. Multiply these three brackets to find the equation. X plus 2 times x minus 4 times x minus 6. X power 2 minus 4x plus 2x minus 8 times x minus 6. Simplify this first. X power 2 minus 2x minus 8 times x minus 6. X power 3 minus 2x squared minus 8x minus 6x squared plus 12x plus 48 equal to 0. Or f of x equal. Then simplify this equation. X power 3 negative 2x squared negative 6x squared negative 8x squared minus 8 plus 12 plus 4x plus 48. This is our equation. Question number 27. Match each function to its table. I solved two of them before. For the first equation, I solved it before. It is the first table. And the third equation is the second table. This is y equal kx plus 5, and this for y equal kx to the 3 over 2. I solved it already before. Let me check which table is for equation number 2. Let me check this table. When y is negative 9, x equal 1, 1 plus k, then k is equal to negative 10 from the first point. From the second point, when y is 6, then x is 4, 4 power 2, 16, 16 plus k, then it gives me k equal negative 10. So This function is for this table, y equal x power 2 plus k. Let me check the last one, the last point, when y equals 71, then 9 square, it's 81, plus k. Okay. Therefore, the last equation is for the last table here, x, y equal to k. Let me check it. Write this equation as standard form, y equal to k over x, when y is 36, then k equal 36. When y equal 9, then k equal to 4 times 9, it's 36. Question number 30. If b square minus 4ac, it is the term under square root from the quadratic formula. If b square minus 4ac greater than 0, then f of x has only two x-intercept. It is right. When b square minus, in quadratic formula, x equal minus b minus plus b square minus 4ac over 2a. When b square minus 4ac greater than 0, then this function, this quadratic function, has two real x-intercepts. When b square minus 4ac equal to 0, then the function, the quadratic function, ax square minus bxc has only one x-intercept. When b square minus 4ac less than 0, then the function has no x-intercepts. See you next lesson.